Today's lesson is on the factor theorem. We'll be adding this to a current page in our notebook. So if you'll please pay attention to the page number on the next slide and add this to that current page number. The factor theorem. The factor theorem says a polynomial f of x has a factor x minus k. Now you know all the time that we've been doing these transformations, think of this as like being inside with x. So if this is inside with x, then you're going to use k, or the opposite. So f of x has a factor x minus k if and only if, when you substitute k in to the function, you get 0. So you can tell if a binomial is a factor of a polynomial if you take the constant, substitute it into the function or into the polynomial, and you get 0. Now another way to think about this, some teachers will tell you if you have the factor theorem that you would do synthetic division. You don't necessarily have to. You can, but you don't have to. You're going to substitute, that's really what the factor theorem says, is to substitute k in to find if it's 0. But if you did synthetic division and you got a remainder of 0, then that means it's a factor. But you'll see on the problems that I do on the next slide, I will do what the factor theorem says, to substitute. Substitute that constant into the function. Okay. It says, show that the binomial is a factor of the polynomial. So as I look at this, I've got x plus 1, x minus 2, x minus 5. I'll go through each of these and we'll write down k, the value I'm going to substitute in before I actually do it. So I want to decide, is x plus 1 a factor of this? And if you looked at this right now, you could not tell if it's a factor, or you couldn't factor this because it's not in the correct form to factor. Okay, so let me go through and write k for each of these. K is going to be -1 for 15. K is going to be +2 for 16. And then K is going to be 5 for 17. Now, that's the first thing that we're going to do, is show that it's a factor. So it is a factor. It's not a question if it's a factor or not. It is a factor. So we're going to show it is a factor by getting an answer of 0. After we do that, we're going to factor the function completely. Okay, so I've actually changed my mind now that I read this. I'm going to go ahead and do synthetic division. Since it wants me to factor the function completely, I don't want us to have to do too much work. So we're going to use this to do synthetic division with our function. I want you to remember you are looking at x cubed, not an x squared. -13x, -12. So we have to put that placeholder in there for our squared term. I've got 1x cubed. I have 0x squareds, -13x, and -12. And I'm going to go ahead, because I'm confident, I'm going to put 0 in this spot because I know it's not going to be a remainder, because it tells me up here that this binomial is a factor. Okay, so I'm going to bring down the first one. -1 times 1 is -1. Add, multiply, add, multiply, and when you add, you get 0. And now what I'm going to do is, my final answer I'm going to put over here. Hope I'll make my box big enough. Right now I know x plus 1 goes in my final answer. I'm going to take my new trinomial. My new trinomial is, remember, you're doing x cubed divided by x, so x squared goes here. My new trinomial is x squared minus x minus 12. So I want to find factors of a times c that will give me a sum of b. What can I multiply and get -12, and add and get -1? Hopefully -4 and 3 immediately came into your mind. So then I have x minus 4, x plus 3. And that goes down here. This is the second answer to the problem. Here's the first answer. We showed that it is a factor because we got a remainder of 0. And then we factored the function completely. Okay, let's go on to number 16. I'll put 2 here. I will look for, I have cube, squared, yep, I'm good. 6, 8, negative 34, negative 12. Bring down the 6, 2 times 6 is 12. Add 8 plus 12 is 20. Multiply 2 times 20 is 40. Add negative 34 plus 40 is 6. Multiply, I get 12. And I know I'm correct because I was supposed to get a remainder of 0. Now I'm going to go ahead like I did on my last one and put my answer here. X minus 2 I'll put as my first one. Okay, I'm going to divide x cubed by x, and that is x squared. So I'm going to have 6x squared plus 20x plus 6. Okay, immediately I see I have a common factor of 2. So I'm going to have 3x squared plus 10x plus 3. Can I find factors of 9 that will give me a sum of 10? Yes, 1 times 9. Now remember, since a is not 1, I'm going to put a 3 here. 3x plus 1 and 3x plus 9. Then I'm going to look at both of those binomials. This first binomial does not have a common factor, so in just a moment I'll bring it down. This second binomial has a common factor of 3, so I'll divide both of those by 3. So I'll bring down 3x plus 1 and bring down x plus 1. We just factored 6x cubed plus 8x squared minus 34x minus 12 completely. There is the complete factorization right here. Okay, let's do the last one. I'm going to use 5, 4, 3, 2, 1, and I may or may not need that last one, but I'll go ahead and put it. So 2, negative 12, 6, 20, and I'm going to go ahead and put this, I don't know if I'll need it. Let me see. Bring down the first one. 5 times 2 is 10. Add, negative 12 plus 10 is negative 2. Multiply 5 times negative 2 is negative 10. Add, I get negative 4, and I don't think I'm going to need that last one. 5 times negative 4 is negative 20. Add, and I get 0. So let me erase that off the end. Sometimes you need it, sometimes you don't. So I'll just go ahead and put that there. And see, it would be useless for me to continue. 5 times 0 is 0, 0 plus 0 is 0, so that would be useless for me to continue. Okay, so now as I look at this, I am going to write, let's see, x to the 4th divided by x would be x cubed goes here. I'm going to go ahead and put my answer down here on the bottom. So I'm going to have x minus 5 down here. And I'm going to have 2 more binomials. Then let's see, I've got 2x cubed minus 2x squared minus 4x. I see I have a common factor of 2x. When I divide by 2x, I get x squared minus x minus 2. I'll bring down that 2x down here so I can forget about it. Can I find factors of negative 2 that'll give me a sum of negative 1? Yes, negative 2 times positive 1 multiplies to give me negative 2, adds to give me negative 1. So this would be x minus 2, x plus 1. That's what goes down here. So we just talked about the factor theorem, and I want to tell you again, I only use synthetic division because of the second step I had to do. If you were just trying to find if something was a factor, then the factor theorem really says for you to use substitution. Now, I use synthetic division just for selfish reasons, but it really says for you to use substitution. Substitute -1, as I look at this first one, substitute -1 in for x and evaluate it and see if you get 0. Substitute 2 in for x and evaluate to see if you get 0. And then substitute 5 in for x, evaluate, and see if you get 0. So I just wanted to clear that up. Thank you so much.